Okay, so I'm gonna start with something that genuinely caught me off guard when I first saw it, and I still don't understand why it isn't blowing up more than it is. Samsung is building a chip that lets your phone talk directly to Starlink satellites, not through a cell tower, not through your home router. Your phone straight up in the sky, locking onto a satellite flying hundreds of kilometers overhead. Let that sit for a moment. You're out hiking somewhere, completely off the grid. Phone shows no bars at all, and instead of being stuck, it just quietly connects to a satellite passing by and you're back online. That is the world Samsung is working towards right now, and there is actual documented evidence for all of it. This isn't a leaked patent or some analyst's wishful thinking. This is real. So let's actually get into it, because there are a few layers here and each one builds on the last. In October 2025, Korea Economic Daily broke the story. For context, KED is essentially the go-to source for Korean semiconductor and tech industry news. So when they say a senior Samsung executive sat down with SpaceX officials to walk them through development progress on a new chip, that's not some vague tip. That's a confirmed business meeting between two of the heaviest hitters in tech. What Samsung System LSC division is working on is a new Exynos modem, but this isn't just a regular modem with a satellite feature tacked on. The thing has an AI accelerator built directly into it, a neural processing unit or NPU baked right into the silicon. And the reason that matters is because tracking low Earth orbit satellites is actually a brutal engineering problem. These satellites are ripping across the sky at thousands of kilometers per hour. Current chips have a hard time maintaining beam alignment, staying locked on, keeping the connection stable. Samsung's answer to that is making the chip predictive. It doesn't just react to where the satellite is, it calculates where it's going to be and starts preparing the link in advance. According to the benchmark data from Samsung's internal presentation materials that KED got access to, this modem improves beam identification performance by 55 times and channel prediction by 42 times compared to what exists today. That's not a spec bump, that's a complete rethinking of how the hardware works. Then, in late December 2025, Samsung officially listed the Exynos Modem 5410 on their semiconductor product portal with mass production confirmed. So at that point, it stopped being a rumor entirely. The 5410 is built on Samsung's 4nm EUV process. It supports 5G across both sub-6 GHz and millimeter wave bands simultaneously, with peak download speeds up to 14.79 GB per second, which is fast in a way that almost feels unnecessary until you remember that this is going into a phone. But the part I keep coming back to is the satellite side of things. The 5410 is the first modem chip in the world to put 3 different satellite communication standards onto a single piece of silicon: LTE direct to cell, NB-IoT NTN, and NR-NTN. All 3 one chip. Here's what those actually mean in normal language. LTE direct to cell is what makes real satellite voice and video calls possible without any ground infrastructure in the loop. NB-IoT NTN is the lightweight layer, handling text, location data, that sort of thing, and it works anywhere you can see the sky, whether you're in a desert or on a boat in the middle of nowhere. NR-NTN is the higher bandwidth option. Think proper video calls and actual data streaming over satellite. Now compare that to the Galaxy S25, which came out not long ago. Its satellite features lets you send emergency text through Verizon and Skylo. That's it, 3 to 6 seconds send time. No voice, no video, pure SOS. The 5410 makes that look like the first generation of everything. Samsung also added hybrid post-quantum cryptography to this chip, which is the first hardware-level implementation of its kind on a mobile modem. So, on top of everything else, it's built to resist the kind of attacks that quantum computers will eventually be capable of. They're not just solving today's problems here. Samsung isn't doing this in isolation though. SpaceX has been pushing hard towards direct-to-device satellite connectivity for years now, and the infrastructure they've been building is exactly what makes Samsung's chip relevant. Starlink satellites already carry NB-IoT modem on board, which is essentially a cell tower floating in orbit paired with phased array antennas and laser backhaul that lets each satellite connect to any point on Earth. In October 2025, SpaceX unveiled their V3 satellites, which are roughly 3 times larger than the previous generation, up to 1,250 kilograms each with 60 terabits per second of downlink capacity per satellite cluster. They're built for gigabit speeds and optimized specifically for direct-to-device connections with AI-assisted signal handover. The launches started in early 2026. Now, Starlink's direct-to-cell service commercially launched through T-Mobile in the US in July 2025, and it already has over 12 million people using it where terrestrial networks don't reach. They have carrier partners in the US, Australia, Canada, Japan, Switzerland, the UK, Ukraine, and more. And according to KED, Samsung is actively in talks to join the component supply from SpaceX's non-terrestrial 6G network. The market this whole ecosystem is targeting is projected to hit $530 billion by 2040. Samsung isn't approaching this as a side project. Now, for anyone who's actually using Samsung phones, here's where it gets close to home. The Exynos Modem 5410 has arrived with the Galaxy S26 series, and the way it's being integrated is actually a structural shift for Samsung. The Exynos 2600, which is the world's first 2nm smartphone chip and is powering the S26, no longer has a modem built into it. The modem is now a separate external component for the first time in Samsung's flagship line. Apple has been doing this with iPhone for years. The benefit is heat management and letting each piece of silicon be turned independently without compromising the other. In January 2026 at CES, Samsung and Keysight Technologies did a live validation demo of the 5410 in real, non-terrestrial network conditions. They showed satellite-to-satellite mobility using commercial-grade silicon, end-to-end link performance, and cross-supplier interoperability. Not a closed-loop lab setup, a real standards-based test environment, and the chip is also certified by Skylo Technologies and built to 3GPP Release 17 standards, meaning it's designed to work across the broader industry and not just within Samsung's ecosystem. Alright, here's my take, and I genuinely mean this. What Samsung and Starlink are building together is one of the most consequential things happening in consumer tech right now, and it barely comes up in most conversations about where smartphones are going. Over 50% of the world's land mass has no terrestrial cell coverage. None at all. People in those areas either spend a lot of money on satellite hardware or they just don't have reliable communication. What this chip does is fold satellite connectivity into a device you already carry in your pocket with no extra subscription, no dish, no special hardware at all. Your phone becomes its own satellite terminal, and that is a genuinely different world. I find that kind of exciting on a level that goes past specs. Think about who this actually helps: a farmer working remote land, a fisherman out in the sea, a journalist in a conflict zone, a family in a region that nobody's built towers in because it wasn't profitable. All of them get the same connected device as someone sitting in a city center. That feels like the kind of progress that is worth paying attention to. And yes, there are real hurdles. AI-driven signal processing is power-intensive, and battery life on early NTN devices is going to be real constraint. Full 6G NTN coverage is targeted for 2030, so we're still a few years away from being fully baked, but the pieces are coming together faster than most people realize, and the Exynos 5410 is a clear signal that this isn't a distant roadmap. It's already in mass production. Samsung threading its chip into Starlink satellite infrastructure while putting that same chip into your next Galaxy phone is a smart play, and honestly, good for the world too.